The universe is expanding, galaxies race away, light stretches to red, and time itself hurtles forward. But here's the riddle that breaks our intuition. If the universe has no edge, what is it expanding into? Not empty space, not a void, something far stranger. And the real mystery, it isn't out there, it's hidden. And the truth is stranger and far more unsettling than you might think. Whenever you hear the universe is expanding, your brain immediately resists. Expanding where? Expanding into what? It feels like expansion must require an outside. Growth needs a container. Movement needs a destination. Yet, cosmology tells us something counterintuitive. The universe has no outside, no beyond. The problem isn't the science. The problem is our intuition. We're used to objects inside other objects, water inside a glass, air inside a balloon. But the universe isn't an object, it's the container itself. So, to really understand what scientists mean when they say the universe is expanding, we have to step back. We have to ask a deceptively simple question: what do we mean by universe? The word universe sounds straightforward, everything that exists. But scientists use it in different ways depending on context. Sometimes it means the observable universe, everything we can see from Earth. Other times it means entire universe, the totality of reality, whether observable or not. That distinction is crucial because when people imagine expansion, they often picture the observable universe swelling like a bubble in a larger space. But that isn't what cosmology actually describes. And to clear up the confusion, we need to understand what the observable universe really is. Light travels at a finite speed, and the universe has a finite age, about 13.8 billion years. That means there's a maximum distance light could have traveled to reach us since the Big Bang. The distance defines our cosmic horizon. Here's the twist: because space has been stretching the whole time, the edge of our observable universe isn't 13.8 billion light-years away, it's about 46 billion light-years away. So, the observable universe is a vast sphere centered on us, about 93 billion light-years across, and beyond that lies more galaxies, more space, perhaps infinite, but hidden from view because their light hasn't had time to arrive. This is where the first misconception creeps in. The edge we picture isn't a wall or a border, it's just the edge of what light can reach us. And beyond that, reality keeps going. If that feels strange, we're not the first to wrestle with it. Humans have always tried to imagine boundaries. For most of human history, the cosmos was imagined as finite and enclosed. The Babylonians pictured the universe as a flat disk resting on a cosmic ocean. The Egyptians imagined the sky goddess, Nut, arched over the earth, her body holding back chaos. The Greeks spoke of crystalline spheres with stars and planets set like jewels in glassy shells. In every case, the universe wasn't everything. It was inside something larger: water, chaos, or divinity. There was always an outside. Even in the Middle Ages, the idea persisted. The outermost sphere of stars wasn't the end, it was just the threshold to God's realm. Back then, no one asked, what is the universe expanding into? Because the universe wasn't expanding. It was eternal, unchanged, and bounded. But then came the scientific revolution. Copernicus placed the sun at the center, pushing Earth from its throne. Galileo pointed his telescope skyward and found moons circling Jupiter, proving the heavens weren't perfect. Newton wove it all together with his laws of motion and gravity. Newton's vision was radical, an infinite, eternal stage called space. On that edge, matter danced, pulled by gravity, governed by universal laws. In that framework, if the universe expanded, it would mean galaxies rushing into pre-existing empty space, a cosmic explosion in a cosmic void, and that picture, galaxies flinging outward into darkness, is still the instinct many of us carry today. But Newton's infinite stage was destined to be replaced. The 20th century brought a new revolution. In 1915, Einstein unveiled general relativity. Suddenly, space and time weren't rigid scaffolding, they were a flexible fabric, bending under the weight of mass and energy. Gravity wasn't a force at a distance, it was geometry itself. In this new picture, the universe wasn't matter moving inside a container, the universe was the container. So, when we say the universe is expanding, we don't mean galaxies flying outward into empty space, we mean the fabric of space itself is stretching, distances grow, galaxies drift apart, but no outside is being invaded. Einstein's equations even allowed for something mind-bending, a universe finite in size but without edges, like the surface of a sphere. You can keep traveling forever without ever falling off. This is the moment when the question, expanding into what, starts to dissolve. But theory alone wasn't enough, we needed observations. To make this shift in thinking a little easier, scientists turned to analogies. The most famous is the balloon. Imagine the two-dimensional surface of a balloon with dots drawn on it. As you inflate the balloon, the dots move further apart, not because they're sliding across the surface, but because the surface itself is stretching. That's our universe. Galaxies aren't racing through pre-existing space. Space itself is growing. But there is a danger here. Balloons expand into the air around them. Our universe, as far as we know, doesn't expand into anything. The analogy works only if we focus strictly on the surface, not the surrounding air. And just when the balloon was becoming a useful teaching tool, real data arrived to prove expansion was more than a metaphor. In the 1920s, Edwin Hubble made a stunning observation. Distant galaxies weren't just moving away, they were redshifted. Their light was stretched to longer wavelengths, a telltale sign of expansion. Even more striking, the farther away a galaxy was, the faster it receded. This wasn't random motion, it was a pattern woven into the structure of space itself. Hubble's discovery forced us to abandon the last traces of a static universe. The cosmos wasn't eternal and unchanging, it was dynamic, evolving and expanding. But to really grasp the strangeness of expansion, we need to go back even further, to the very first instant. Roll back the cosmic clock to the first fraction of a second after the Big Bang. Cosmologists believe the universe experienced inflation, a burst of expansion so rapid it outpaced even the speed of light. This doesn't break relativity, because relativity limits the motion of matter through space, not the expansion of space itself. Inflation smoothed out the universe, stretched tiny quantum ripples into seeds of galaxies, and explained why the cosmos today looks uniform on large scales. But inflation may not have ended everywhere. Some regions might still be inflating, spawning new bubble universes. So our universe isn't expanding into nothing, it's just one pocket in an endless multiverse. Which brings us back to the haunting question, what lies beyond? There are three main possibilities. One possibility is that there is simply nothing beyond. By definition, the universe is everything, space, time, and matter together. In that case, asking what lies outside, it's like asking what's north of the North Pole. But there's another idea. If cosmic inflation is correct, our universe may just be one bubble in a vast multiverse, surrounded by countless others, each expanding within a larger inflating background. And then there's an even wilder possibility. Some theories suggest our entire cosmos could be a three-dimensional brain, floating in a higher dimensional space. In that view, what we call expansion might be our universe moving through an unseen realm. None of these ideas are confirmed, but all challenge our instinct to imagine edges, boundaries, and containers. So, what does expansion really mean? It means galaxies are drifting apart. It means our cosmic horizon is always shifting. It means that one day, most galaxies will slip so far away, their light will never reach us. Expansion isn't a race toward a border, it's the stretching of distances themselves. And since the universe is unbounded, no edge is being crossed. The universe is expanding, not into something else, but within itself. But why does this puzzle feel so unsolvable? Because our minds evolved to think in containers, liquids in jars, clouds in skies, explosions in air. We crave an outside, a backdrop, but the universe defies that craving. It isn't inside a bigger box. It isn't sitting in empty space. it is the totality of space, and realizing that forces us into a more alien kind of thinking beyond the comfort of everyday intuition. Asking ourselves where does this all lead, cosmologists envision two main outcomes. One is the heat death. Expansion continues forever, stars burn out, galaxies fade, eventually the universe becomes cold, dark, and silent. The other is the big rip. If expansion keeps accelerating, it could someday tear apart galaxies, stars, planets, and even atoms themselves. Both scenarios unfold entirely within the universe's fabric, neither requires an outside. So, let's return to the question, if there's nothing outside the universe, what is it expanding into? The best answer? Well, it's this: nothing at all. Expansion isn't about rushing into a void, it's about the stretching of space-time itself. The universe doesn't need an outside, it is the outside, the totality, the stage, the fabric of existence. So, the next time you look up at the night sky, don't imagine galaxies racing towards some cosmic edge. Instead, picture reality unfolding within itself, an endless, expanding mystery carrying all of us along for the ride. If questions like this keep you up at night, don't let the journey end here. Hit like, tap subscribe, and join the search for answers that push past the edge of what we know.